Conversation in a Tack room. Elizabeth Yule, DVM, PhD, Deep DACVP. Jean-Luc Cornille, Science of Motion. Today's subject is kissing spine.
So today we talk about the kissing spine. Every time I rehabilitated errors was kissing spine. I did not focus on the dorsal spine. I focused on recreating proper coordination of the thoracic spine, thoracolumbar spine. I always have this confused impression that was a problem. Then the dorsal spine touch, but I could not explain it. That's why I was so happy that Betsy started to look at it on the necropsy room to figure what is the problem. The rose was sound, but 1 or 2 years later we take X-ray of the dorsal spine and they were at the same place. They did not separate. It was no longer a sign of remodeling, but they were on the same place, but the rose was sound. A kind of a mystery. So I'm very happy that Betsy decided to look at it from the scientific perspective.
Yeah, well, first, we've got a case of kissing spine here so we can look at it again. But when you think about it, to get the dorsal spines to contact each other, you have to have hyperextension of the spine. So you can see this in this tensegrity model. This is a tensegrity model of the spine. The white are the vertebra. And to get these, and these are the dorsal spines, the way I've got it arranged here. And to get those to touch, you got to do this. So you get hyperextension of the spine. The other thing we see if you just had hyperextension of the spine, you'd say, well, it's pulling apart at the bottom. But as you'll see in the case, there's actually, you're getting hyperextension in combination with compression. And we'll show you the lesions for that. So here is the thoracic and beginning spine of a horse that had kissing spine. And what you notice as we've arranged it is that it's hyperextended, that you can see this is arched up. Okay? If you move down to look at some of the lesions, you'll see that the dorsal spines are touching each other. The dorsal spines are touching each other. And where they touch each other, you can see proliferations of bone. So right along in here, you're seeing bone, where it touches, you're seeing bone forming. And as you move along the spine, and you're getting back in here, which is actually right where the rider would be sitting, you can see even more proliferation of bone. And they're and the next one is kind of arched out. Okay? So when they are diagnosing kissing spine, they can see this part, right? Usually this part. A little harder to get up in here, but this is what they're seeing. They're seeing the dorsal spines are touching and are in contact with each other. What was interesting, I'll hand the camera to Jean-Luc for a minute so we can show this, okay? A little better. Is that if you turn this upright and you look at how the facets, now the facet joints, these are the facet joints. They're little flat joints right here, and they articulate like that. As you move back into the area where we're seeing a lot of the lesions, again, see these little sort of almond-shaped articulation right there? But as you move back to where it's more severe, you see bits of bone forming here, okay? That's formed because these facets have been pushed. You see how it's pushed in? So there's compression in this area of the spine so that you can, and that's why the bone has formed along the edges of it. So they're not only hitting at the top, You can see it hitting at the top here, but they're also compressed at the base of the vertebra. And as we move along, they get more irregular. And again, you can see that bone. What's happened is as the compression was put on here, the body reinforced against the compressive forces by forming bone along the edges and also changing the shape of the facets. And this goes on here. This horse, for example, there was more compression on this side than this side. See how there's more bone along there? And so as we put this one together, you can see the articulation of the bone forming along to stabilize the articulation and deal with the compressive forces. And you can also see how the compressive forces have bulged the bone out here and sort of hollowed and flared it in the back. So those are the lesions that we see. You can see how irregular this is. These shouldn't really be touching. But when they do touch, when bones come together in compression, you get deformation of the bone and you get proliferation of the bone to deal with the compression. Okay, so what we're seeing, but if you look at the primary mechanical dysfunction, so the primary mechanical dysfunction that we see in this spine is hyperextension and compression, okay? And you can potentially see how compression is going to push all this together. What's interesting is that we could predict that there would be hyperextension in the spine. But again, looking at it more closely, we're also seeing compression. So Luc has noted things in terms of rehabbing the horses that is consistent with this. So we'll let him explain what's going on or what he's felt.
So when you have a case of kissing spine, if you try to separate that, there is no way to do it. The only way will be to cut the supraspinous ligament, but then you have serious problem of stability. So you have to do it from here. You have to reorganize the vertebral column. So for example, theoretically, it's easy. Theoretically, we should just do that and the vertebrae separate. But the entire horse is organized this way. And therefore, we cannot do it this way. So we have to observe what's wrong. Very often, the trunk is too low between the shoulder blades. And when they go like that go down. So often the solution is to lift the trunk between the shoulder blade by gymnastic exercise. Then to recreate flexion, reorganize the vertebral column. You have to create flexion of the thoracic spine. But the flexion does not occur vertical. The flexion, lateral bending is always coupled with rotation, flexion. So it's a reorganization of the entire body. That was sometimes you have to do it from the lateral bending, knowing that the rotation occurs like a lift, and the rotation will help to lift this part. Sometimes you have to start with a hand leg, because the adduction of the hand leg creates a rotation, and the rotation helps to create a lift. Then the croup, the rods need to be properly worked, in fact, properly collected, because if the croup is up, that's aggravates the problem. So we have to have the spine properly organized to permit a dorsoventral rotation of the pelvis, which can only occur if that is up. So you have to analyze the horse and see how the horse moves, and decide a program according to the way the horse moves, the way the horse uses his body. So sometimes you start by lifting the trunk, sometimes the lateral bending and the rotation, sometimes the rotation. But every time you reorganize the vertebral column properly, so you recreate proper function of the vertebral column, the problem of kissing spine disappears. The horse functions perfectly normally. And he will function normally as long as the rider will keep the horse, the vertebral column, function properly. The second the rider will go back to push and pull and all the wrong type of running, the problem will come back. So kissing spine, it's an ongoing problem. You can relatively easily teach a horse to function properly, but you have to work properly all the time.
And again, what Jean-Luc was just describing, all those exercises, one of the effects is going to be to relieve the compression between the vertebrae. And I'm not sure that's really been understood in kissing spine. You've got a combination of hyperextension and compression. You relieve the compression, you also relieve the hyperextension and the dorsal spines touching each other. So you really have to go back to, again, the root cause. I hadn't realized how much compression was going on in these cases, and it seems like the more and more cases that we do, compression is a huge problem in quite a lot of lamenesses.
That is very true. And as you have to, as the horse change, you have to change. The horse is not going to fix everything in once. He's going to react when you lift, for example, the base of the neck. Is going to react differently to protect what he's used to do. And therefore the reaction might be completely different. And then you have to follow how the horse thinks and help him do the analysis for the horse and help him to reorganize the body all over the place. The compression, it's a problem. So if they work heavy on the forelegs, they are very likely to get kissing spine. If they break a lot with the front leg because they are heavy, long and low, all those things, they are very likely to develop kissing spine. So you have to put them in balance. You have to teach them the concept of balance control. But balance is centering the force around the center of mass, which is somewhere here. Therefore, balance includes straightness, lateral bending, rotation, everything. We need to narrow the corridor to teach the horse to master all the force above and around the center of mass. So it's basically ride properly. The therapy for kissing spine is to work the horse the way it should have been worked in the first place. And if it had been worked like that on the first place, he probably will never have developed kissing spine.
And also, as a comparative note, kissing spine also occurs in people. And it in particular in gymnasts, women gymnasts in particular. So when you have this hyperextension of the lumbar spine, they get it in a little different place. And if you think about it, you've got a hyperextended spine, and then you're putting forces on it. That's going to magnify compression, because it's hyperextended. There's less ability really to disseminate the forces. So it's really a combination of both. But again, kissing spine, we're seeing evidence of both hyperextension and compression.
And that is probably why when horses are rehabilitated, they are sound. You take X-ray 2 years later. It's a horse, we did it. And then there was no sign of pressure, no sign of remodeling there. That was a compression. The horse was dragged, was the usual type of training, drag forward on the forehand, and then put him in real balance, authentic balance, is the compression. And that's probably why when we take X-ray 2 years later, there was no sign of remodeling, there was no sign there. But the vertebrae were not separate, they were in the same place, but there was no sign of pressure force.
Right, and you can see where the bone has formed, where the dorsal spines have hit against each other. That probably isn't going to go away. But that's not the problem. That's been what the body's done to reinforce the spines against the compression from hyperextension. So one thing that isn't always understood is it's not the lesion per se, it's the mechanics that did it. And our bodies adapt to mechanics. Our bodies put bone where it's needed to deal with excess forces. So you wouldn't necessarily expect, even in this case, if you'd rehab this horse so that it functioned well and didn't have any signs of kissing spine, you wouldn't necessarily expect that the bone proliferation would just go away. So we have to really be understanding lesions that are compensations for excessive force and not the cause of it.
That is why trying to do surgery to remove all the remodeling does not work. If you don't suppress the cause of the compression, if you don't suppress the compression, it will come back. Right? So it will be okay for a short period of time, but it will come back.
Is the model down there, John? Brings up an important point about the surgery, in that if you understand that the bones are suspended in the soft tissue, so in this case, this is a tensegrity model of the spine. It's based on the most current research about how the spine works. And what you're seeing is all these red areas are the soft tissue. So when you're dealing with kissing spine, you're dealing with this kind of thing. Okay, so the soft tissue's all been compressed between the bones. So if you go in, think about this, you go in and you cut this out, you're going to destabilize the whole back. And that's been some of the problems that have come up both in spinal surgeries in people and in horses, that the focus on the bones and just thinking that the soft tissue holds things together has led to some things that don't work. So what they do is there's pain. The pain receptors are in here, so they just kind of go and cut that out. But again, if you look at this spine, look at this horse spine. Okay, let's say the main place this horse was sore was right here, and you just cut this out. You haven't done anything about the real problem. The back's still hyperextended, plus by cutting all of the fascial and soft tissue attachments which extend through the whole spine, you've just put a concerning focus of destabilization in the spine. And again, that's something they're finding out with humans as well.